Testing, testing. Testing, testing. Testing, testing. Testing, testing. All right, everybody. Good morning. It's the first time that we've tried this. I'm going to leave the live stream. You guys are expected to follow along as we go through today's lesson. We're going to try that out and see how it works. We'll see how the participation scores go today. I do know that there is a lag between my feed and yours, and I've adjusted the way that we process the participation information to account for that. So again, but the goal is to try to do this kind of the way we would do it in class. So the commenting may be a little bit awkward in the sense that there is a lag. So it looks like it's maybe between about 5 and 10 seconds between me saying things and you guys hearing them. So if you'd have a question, please jump on the comment section. There are some course staff hopefully that will be there to help out. If I see something come up in the comment section, I do have it visible. So if I see something come up, I'll try to come back to it. But by the time I get to it, by the time kind of you guys ask and I see it, it might be a little bit, you know, a few minutes might have gone by. So also if you comment, you don't hear me address it immediately, please don't take that I'm ignoring it. I just haven't seen it yet. All right, so let's get started. So last time we talked about interfaces. We introduced the idea of a way, this is a new way to implement a different type of polymorphism. And we talked about how ubiquitous interfaces are between lots and lots of different parts of a computer system, right? And so this idea is an idea that reemerges as we see lots and lots of different types of computer systems being built. So interfaces exist. So this interface is a boundary. Today we're going to look at a specific definition of a Java interface. We'll talk about exactly what it means for two parts of a Java program to declare an interface and what happens across that. But an interface is really just a more general idea, right? And I think a good definition of it is it's a place where two things come together and meet, right? So it's a boundary between two parts of a computer system or a computer program. There are lots of different interfaces that we see when we look holistically at a computer system. So we see interfaces between software and hardware. When you plug in something into your computer, like into a USB port, you're essentially using a hardware interface, right? That's what USB is. It's an agreement. It's a place where two things come together, whatever you're plugging into your computer and the laptop or the computer itself. And like other interfaces, there have to be agreements about exactly how communication is going to happen across that interface. So USB allows any mouse or any peripheral or any video camera or webcam in this case that you purchase to hopefully communicate with any computer that you plug it into, right? There's some other issues related to this, but the hardware interface in terms of what size is the port and exactly how is data exchanged across that, that's an example of an interface, right? We see lots of other interfaces between different parts of your computer system, like between you and the computer itself. So right now I'm standing in front of a large display. This is one of the primary interfaces that I have to my machine, right? This is how it communicates data to me. I communicate data back to it primarily through, you know, my mouse and keyboard. Those are other examples of human-computer interfaces. And one of the things we're going to see today is that one of the most important things that happens when we have an interface is that we need to enable structured communication. So we have to have agreements about how things are going to work, right? USB is more than just the size of the plug, but obviously USB also dictates exactly what the physical design of a plug is. So if you get a device that has USB and its USB port hasn't been designed and manufactured properly, you can't even plug it into your machine, right? So that's an example of an agreement that we've come to whereby we say a machine has a USB port with a particular configuration and devices that want to be able to plug into that have a USB plug with a particular configuration, and now I can sort of link those things together, right? And that's just one of the many types of agreements that are required at an interface, right? Because it's this boundary where two different parts of the system come together, right? A part that was created by one person and a part that was created by another person or another group of people. All right, so last time we talked about a couple of these, and I've already sort of brought them up already, right? So there's lots of examples of different interfaces between two software components that are part of the system. You know, I use the example of the test cases that we write for the MP. That's an example of an interface. That's the interface across which we test, right? So, you know, you can think of each MP description as essentially a description of that testing interface and what we expect your code to be able to do, right? Because we don't expect you to just build an app that implements Campus Snake. You actually have to do it in a specific way so that we can test it, right? We see lots of interfaces between software and hardware, right? So there's software running on my machine, that's computer code somebody wrote, and then there's hardware that constitutes the machine itself. And those two parts of the system, somebody designed the hardware, somebody designed the software, they need to have interfaces, places where they can interact, and across those interfaces, there needs to be agreement about how things are going to work. And then lots of interfaces between computers and users. We talked about a few of these, right? Anytime that you use a computer, what you're really doing is you're using a computer interface, and how that interface is set up ends up dictating a lot about exactly how you use it, right? Okay, so in this particular example, we're going to talk, in this class, we're going to focus on software interfaces. And today we're going to look more specifically at exactly what a software interface looks like in Java. Java has a very specific idea of what a software interface is. So in Java, we have an interface keyword. The interface keyword defines an interface in a way that we're going to look at. Some languages have this concept, right? So Java, Go, there's a variety of different languages for which interface is a very specific idea. It has a very specific meaning. We're going to look at that today. In other cases, interfaces essentially are done by convention, right? So when you use a library in a programming language that doesn't have a language specific or a language internal definition of what an interface is, you're still using an interface because you went to the documentation page and you looked up how to use that component, and that's how that dictated the code that you wrote in your project. And essentially when you do that, what you're doing is you're reading documentation about how to use an interface. All right. But, again, regardless of the environment that you're in, interfaces are this really critical concept to understand in software development and computer science in general, right? They come up all over the place. And so that's why we talk about them in this class, right, today and on Friday. The last thing that just as a bit of review that we looked at is that, every single class in Java has an interface. There is a way to define and implement interfaces in Java, and again, we'll spend the rest of today's class looking at that, but you don't have to do that to have an interface. The interface to an object in Java constitutes the methods that you can call on that object. So if an object has a public method, that's part of its public interface. So, every object in Java inherits these methods, public methods from capital O object. We've talked about 3 of them. All of those are part of each class's interface because I can always call those methods. And then any methods that class adds and any of its ancestors added, those are also part of its interface. So more broadly in Java, we'll talk about a narrow concept of what it means to have an interface today, but the broadest and the most appropriate concept of an interface in Java is that it's the collection of all methods that can be called on a particular object. Okay, so let's talk now about documentation, right? So interfaces are also a place where you really, really need excellent documentation, right? So you need a place for, because this is where two things that have been developed by different people have to come together, right? So how do we enable that? So interfaces are the place where two things meet. And so if those things are going to actually work together properly, we need lots of different ways. We need lots of documentation at that interface so that we can make sure that interaction happens appropriately, right? Usually when you read documentation about a piece of software, right, what you're actually reading is you're reading interface documentation, right? You're reading the documentation provided for the interface of the particular tool that you're using, right? Okay, so, and this is, essentially the primary purpose of JavaDoc, right? This is what JavaDoc is designed for. So let's look at our first example of an actual Java interface. So here's an interface, right? And at first glance, right, you can see we're introducing a new keyword here, right? This is the interface keyword. And on some level, this looks a little bit like a class declaration, right? I have a public keyword here that indicates that anybody can implement this interface. And I have the name for the interface. And then the body, right? So the difference here is, again, this looks a lot like a class definition, except the body of my interface. So what is this, right? This looks a lot like a method declaration, right? This looks a lot like the way that I would declare a method I have the return type here, which in this case is int. I have the name of the method, which is lowercase add. And I have a list of parameters that the method accepts, right? So in this case, first parameter is first, the second parameter is named second, and they're both ints, right? Now, what's weird about this is that this looks a lot like a method declaration, except for the fact that there's no body, right? So I have a method declaration and I have a semicolon here, but there's no actual body of this method, right? And so again, to reiterate, a Java interface looks a little bit like kind of like an empty object, right? There's no implementation of any of the methods that are contained within this interface, just the method signature, right? Remember when we talked about how Java does method overloading, we talked about what a signature is. So it's the collection of the return types and the parameter types, and in this case, a name, right? Okay. Interfaces can declare both methods and variables just like a class. However, the interface variables have to be public static final. And essentially that means they're only useful for declaring constant values. Remember, we talked about public static final. Why do we declare a variable public static final? It's to establish a constant that we're going to use throughout our program, right? A symbolic constant like pi, or various parameters that our program needs to be able to operate that we want to refer to using human readable names within our program, but are never going to change. In this class, we're not going to talk very much about this use of interfaces. We're not going to talk about interfaces to declare constants. We're essentially going to look at an interface as a way to declare methods. So we're going to focus on interfaces that include method declarations, right? Just like this one. All right. So an interface, one way that we'll talk about interfaces is kind of as a contract, right? Between two parts of a computer program. So an interface says that, by implementing an interface, which we'll look at in a minute, we essentially say, I declare that I am going to implement a method called add. That method will take two integer parameters and return an integer. And typically, and this is missing in this particular example, although it probably shouldn't be, an interface also includes documentation. It says what add is going to do, okay? So I say, I'm going to implement this interface named add that consists of one method. That method is going to take the two parameters and return their sum. I don't declare how I'm going to do that, right? What I'm declaring is that I can do that I have this capability, right? This is what the interface, the person who implements the interface says, right? They say, my object or my class can do this thing, right? You don't have to worry about how. You just have to understand that this is one of the things that my class is capable of doing, that object instances of my class are capable of doing. So now let's look at how we implement an interface, okay? So here in this example, we have both an interface declaration, which starts on line 1 and goes through line 3. That's, again, declaring an interface. The name of the interface is add. We name interfaces using the same naming convention that we use for classes, essentially. Capital A, add, and so we use capital names for interfaces, just the same way we do with classes. And then again, the interface says that to implement this interface, you have to implement a method called add. So now I have a class, okay? So again, this is a good chance to kind of review some of our class declaration stuff. So I'm declaring a public class called adder, and then this is new, right? So what I'm declaring here as part of my declaration of the adder class is that I implement the add interface. So my class now says that it is going to provide the methods required to implement the add interface. So that means that it will support a method called lowercase add that takes two integer parameters and returns an int. And in this case, now what I'm doing is I'm providing the implementation of that method. Okay. So interfaces, again, by themselves, they don't accomplish anything, right? They establish these contracts between two parts of your system. An interface, in order to be useful, has to be implemented by a specific class, okay? And one of the most useful ways that we'll see interfaces become part of our programs is that different classes can implement the same interface in different ways that reflect differences in how the classes behave. Right? So again, so to declare that you implement a class, your class as part of its declaration uses the implements keyword and then lists any interfaces that you implement. In this case, we just implement one. It's called add, right? In order to implement an interface, you have to implement all of the methods that are declared to be part of the interface, and you have to implement them with the proper signature. And as we'll see later, when you implement an interface, the interface almost always, I would say 100% of the time, includes some documentation about what the method is supposed to do. And your class should try to follow that, right? This is an important part of the contract that an interface represents between somebody who's using your class and your class that's implementing or providing the interface. All right, so let's play with this a little bit. Okay, so to start with, I've got my interface. My interface is called capital A add. And again, it declares one public, it says that in order to implement add, you have to implement one method named add that should take 2 integer parameters. And again, it doesn't say how I'm supposed to do this. It just says here's what you have to implement. Now here, what we'll do is we'll try to run this code, and we see that we have a couple of problems here, right? So let's start working on this. One of the things that we can do with interfaces is that we can cast objects to any interface that they implement. So essentially what I'm trying to do here is I'm trying to cast my adder class to be something that can add, and then I'm going to call the add method on that, right? But right now, my first problem is that my class hasn't declared that it implements the add interface. So the first thing we need to do is do that. So let's declare that we implement add. And now if I try to compile this code again, I get a different message. Now this is from the compiler saying that you didn't implement the methods that you were required to implement in order to implement this interface, right? The interface said in order to implement add, you have to implement this add method, and I didn't do that. So now let's go ahead and actually do this. We'll declare a method that matches the signature, and we'll just return the first 2 together. And now this works fine, right? And this kind of does what you would expect. Now let's go through some examples here. So the first thing I want to be very clear about, right, is that the interface cannot validate that you've done the right thing, right? So let me add some documentation to this method, right? Let's put this here. We'll say return the sum of the 2 arguments, right? That makes sense. That's what I expect this method to do. But now let's say that the person who implemented add is a little bit of a joker and just decided to do something different, okay? So this still works, right? It works in the sense that my class adder has declared that it implements the add interface, and it has provided a method called add that matches what the interface requires, that takes the right arguments and returns the right type. But Java has no way of knowing whether or not you did the right thing here, right? The interface says you're supposed to return the sum of the 2 arguments. I didn't do that. I returned, the first minus the second, and I could do anything I want here. I can return their product, right? I don't have to do the right thing. So just because I have an interface, and even if the interface is properly documented, like mine is, that doesn't mean that just by implementing that interface, you are automatically going to do the right thing, right? So let's spend a little more time playing with this example. So let's add another method to my interface. Let's call it multiply, and then we'll add some documentation. We'll say multiply the 2 arguments. Okay, so now in order to, and let's call this interface something else. Let's call it Mathy or something. And now we'll do this. I have to change this everywhere. I'll call this Mathy instead of add, and then I'm going to call mathy.add. Except for the fact that this, now I have another problem, right? Because my interface has changed, but my class hasn't kept up with it. So my class now needs to implement this other method that's part of the interface. And let's do that. We're going to provide a second method here that does the right thing. Oh yeah, I need to spell it right. There we go. Okay, so now my Mathy can both add and multiply, if I can spell things together. Let's print the result of calling the multiply function. There you go. Okay. So, and this is just a brief tutorial in terms of how these work, right? Very simple interface, very simple class that implements this, right? I can have multiple classes that implement the same interface, right? So I could have another class called that also implements Mathy, and then it would have to provide implementations of the same methods. Okay, good. So one of the things that we just saw in this example, right, is this idea of interface casting. When we talked about objects and object hierarchies, we pointed out that if I have an instance of a class, I can cast that instance to any one of its ancestors. So any class in Java can be referred to by a variable that stores an object reference. And this is the exact same thing with interfaces. So once a class implements an interface, as adder does in this case, right? I can refer now. In this case, I want to look at this a little bit differently. So we're gonna walk through this carefully. So here on line 12, I'm creating a new adder object, right? This is I'm creating a new instance of the adder class. But on the left side, my reference variable add stores a reference to anything that implements the add interface. Okay, and so now what I can do is I can call any of the methods that are defined on the add interface, because I know that anything that I can refer to as a capital add implements this method. What I can't do, which is interesting, is I can't call the multiply method at this point. Why is that? Multiply is implemented on the adder class, and it's a public method. So if I had a reference to an adder, I could call multiply. But not everything that implements not everything that implements add has a multiply method, because the only thing that the add interface specifies is that I have to have a lowercase add method. And so this is similar to what we did with object casting, right? So if I cast something up to a capital O object, I can't call any of the specific methods that class has added, because I could have a reference to another kind of object that doesn't have those methods. In this case, when I cast something to an interface, I'm guaranteed to be able to call any of the methods that interface defines, but I can't call any other methods that the class might have defined that don't exist on the interface. And so I think I have some slides that basically say this. And so again, let's go through this example. In this case, my add interface only specifies an add method. It does not specify that instances of this class all implement a multiply. Sorry, that in order to implement this interface, I have to implement the add method. It doesn't require that I implement multiply. And so anything that implements add has to provide an implementation of the add method. So down here, if I try to call multiply, I'm going to get the same error that I would get if I try to cast something up to an object, right? Which is that I can't find this multiply method. And the reason is the same, right? So let's go through this. So let me now create a second class. I'll call it another adder. I'll have it implement add as well. I'll just borrow the same add implementation that I used from the adder class. And now what I can do is I can essentially say my add reference variable can store anything that can refer to anything that implements the add interface. So this reference variable is declared with an interface type. It can store a reference to anything that implements the add interface. Adder implements the add interface. Another adder also implements the add interface. Now, in this example, now you can see why I can't call multiply, because another adder doesn't have a multiply method, right? Adder has a multiply method, but it's not part of the interface. And so now down here, let's comment out the multiply call, and actually let's say println add.add 10, 20. So you see this is the same, and now just for fun, let's be cute here and make the adder implementation of add actually perform subtraction rather than addition. Okay, so now you'll see an example of two different classes that both implement the same interface, but implemented differently. So my adder class implements the add interface, but it for some reason has decided that that should be done by subtracting the two arguments. The another adder class also implements add and does it properly. Now again, these are toy examples, and so I can understand if right now you're like, this is kind of weird, like why would I do this? There's only one right way to add two numbers together. But the real power of this will become more apparent later today and on Friday when we look at interfaces that actually can and should be implemented differently by different instances, by different types of classes, right? And that's actually where interfaces get their power, right? This idea that I can create one contract and let every class implement it differently depending on that class's specific requirements, right? And again, we'll look at examples of this, I think later today and then definitely on Friday. Okay, good. Now, another thing I want to do as part of just sort of a chance to review a little bit about inheritance and overloading, but also to talk about why we need this is compare this with this idea of inheritance and overloading, right? So this looks a little bit like a situation where the interface is basically like the parent, right? And I'm inheriting behavior from my parent, right? You can kind of map implement onto extends, right? And providing your own implementation is sort of like overriding a parent's method, right? And so here's another way to accomplish a very similar thing, right? Which is that I've created a parent class called add. That parent class provides a default implementation for the add method that just returns 0. And my adder method extends add, and if I want to override that method, I can do that in here, right? So this is, I'll do first plus second. This is very similar to what we would have done in the past, right? So, or something we're familiar with, right? So I have a parent class. The parent class declares a method. My child class can either inherit the parent's method or do its own thing. So again, I have full freedom in this adder class to determine how I implement the add method, right? Because I can't not implement it because I'm inheriting it from my parent, but I have my own choices about how exactly to do this, right? All right, so now I can actually make this even better. We can actually make this even more. We can use a few new keywords to bring these interfaces even more in line with inheritance examples that we've already used, right? So you may remember abstract classes. We talked about them very, very quickly, right? An abstract class cannot be instantiated, right? So it can only be inherited from. It only serves as kind of a parent class for other classes that inherited from it. So an abstract class can essentially define that its children have to implement or will implement certain methods. And there's also something called an abstract, not abstract, this is a typo. There's something called an abstract method. So an abstract method is a method that I don't provide an implementation for in the class. I just force anyone who inherits from my class to implement this method themselves, right? So here's an example, okay? Here I have an abstract class called add. That abstract class cannot be instantiated, but it can be extended. So I can't create an instance of add, but I can create classes that extend from that parent class. And now I have an abstract method, right? And you'll see this abstract method looks a lot like the interface method declaration that we saw before. It doesn't have a body, okay? It looks a lot like a normal method declaration if you ignore the abstract part. So it's public, anybody can call it. It returns an int, its name is add. It takes two parameters. The first one is an int, the second one is an int, but there's no body here, right? There's no body of the actual method. Instead, what the Java compiler is going to force me to do is it's going to force me to implement this method in any class that extends adder, right? Sorry, extends add. So now in this class, before my code will compile, I actually have to provide an implementation for it. So I have to say something like add and first and second, and then return first plus second, right? So now this will work, and you'll notice that I can actually create multiple classes that extend this abstract parent class. And if I do this, each one of them has to implement the add method. So now I'll implement add in my another adder class, and return, well, let's create an example of this, right? So now I'll create another adder, of another adder, and then print the result of calling add on that class, which is going to subtract the two arguments. So if you look at this, right, and then I go back and I look at my interfaces example, right, these look really, really similar, right? So in the interface example, I had an interface called add. I had one class that implemented that interface, was required to provide that method, and then I could create a second class that also implemented that interface and was required to provide that method as well. And I could implement the method differently in the two classes if I wanted to, right? So this, and let's just take out this multiply method because it's kind of just confusing for the sake of comparing this with an approach that uses abstract methods. So this now looks, and I can do this. Oops. No, let's just do this, right? So this I didn't, oh, it's mad at me about check style, you are my enemy. There you go. Right, so this, you know, with an interface and implements the interface, two classes that implement the interface, different implementations, should look now very, very similar, different font size to this, right? So I've got a public abstract class, I've got a class that extends that class that implements that, I have another class that extends that class, and I can essentially do pretty much the same thing, right? So now, what's the difference, right? Why would we use interfaces in the first place? Okay. The biggest problem with trying to use Java's class hierarchy to implement interfaces or to get that type of behavior is that there are times in which we want to mix capabilities from different branches in the Java class tree in a way that doesn't necessarily align with how Java wants to organize objects hierarchically, right? Remember that in Java, every class can only have one parent, okay? And so it has to go somewhere on this tree. And so what if I had some, you know, capability that digits could provide, and maybe vowels could provide, but characters can't provide, and letters can't provide, and consonants can't provide, right? And so I would need to kind of really dramatically reorganize my component tree in order to reflect this, if I could even do that, right? And so the biggest difference between inheritance and interfaces, and one of the most important differences, is that in Java, a class can implement multiple interfaces, okay? Every class has one parent and ends up in one place on Java's kind of class hierarchy tree, but a class can implement multiple interfaces. So in this case, you'll see now I've declared two interfaces. The first interface says in order to implement the add interface, you have to provide an add method that takes two integer parameters and returns an integer. In order to implement the subtract interface, you have to implement a subtract method that takes two parameters and returns an int parameter. And now I have a class that implements both, right? In order to implement both, I have to list them using commas after the implements, and I can put as many as I want here. And then I have to provide the methods that those interfaces require, all of them. So in this case, I'm implementing the add method in order to satisfy the add interface, which requires that I implement a method with that signature, and then I'm implementing the subtract method to satisfy the subtract interface, which requires that I implement a method with that signature. Right? So this is, again, one of the big differences between inheritance and interfaces is that interfaces in Java are something that a class can implement as many of as it wants, right? if an interface is useful to you and you can implement it properly, you can implement that interface and provide that behavior. So again, here's an example of this. You know, if I declare, so let's just, you know, do some examples here. Again, if I declare that I implement subtract and don't provide the subtract method, the Java compiler is going to complain at me. Now I don't have to implement subtract in order to provide a subtract method. I can still do this. But now if I try to refer to this, if I try to upcast this to, or cast this to an interface type, it's going to say that Mathy can't be converted to a subtract. And the reason is that I haven't implemented the subtract interface. So now if I put this back on here, now it's complaining because everything that implements subtract doesn't have an add method. And so now I need to call the correct method, right? So this is, you know, this is one of the reasons why we use inheritance in Java, right? Is that inheritance allows me to basically say, hey, I can do something. My class can perform a particular role in this program or has a particular capability that doesn't depend on its relationship to the other classes, right? And so, you know, we're going to talk a little bit essentially about the class hierarchy in Java being orthogonal from the interfaces that a class implements, right? And the interface system ends up being more flexible for that reason. Okay. I think given the lag and, you know, the chat and stuff like that, I think probably what I'll do today is just get through the material I have, and then I'll stay online to answer questions that people might post in the chat once we're done, right? And I can actually answer those in the chat, or maybe I can talk about a few of them if they're interested. So I want to sort of zoom out again and talk more about kind of exactly what interfaces are for and what they do, right? So now we've looked at exactly what Java means by an interface, but the thing that's going to be difficult for you to understand, having taught this class a few times, but it's also really important, is that interfaces represent this contract between two parts of the system, okay? A good interface, like we talked about last time, allows two parts of your code or two parts of your project or two different systems to be developed completely separately and still work together. And in order for that to work, though, there has to be agreement about certain stuff. So again, go back to the USB example. USB publishes all these specifications for how not only the size of the plugs and the exact layout and physical configuration of those plugs, but also the way that a device that is plugged in to USB is expected to send data back and forth to the device that it's connected to. So there's a whole standard, right? You can actually go and find this online. Like USB has set up a whole standard that dictates exactly how this works, right? If you want to create a USB device, let's say you have a new device that you want to create that you want to be able to plug into any computer, you go out and you download all those documents and you figure out how to build a plug that's exactly the right size and shape, and you figure out how your software is supposed to send data with the exact right format and stuff like that. And if you do that properly, your device can now be plugged into anything that has a USB port. All those other devices that have USB ports were developed by other people that know nothing about you, right? But because you started with a contract, right, a very, very specific detailed document that laid out all of the assumptions that both of you needed to make in order to work together, everything worked out okay. Software interfaces are another form of this. So a good software interface dictates exactly what two parts of the system need to agree on in order to work together. And in order to talk more, productively about software interfaces, we're going to divide the two parts of the system that interact across an interface, okay? So we're going to divide them into a provider and a user, okay? So the interface provider is the class that implements the interface. An interface user is somebody who uses the capability that that class provides through the interface, okay? And if we do this right, these two components can now work together while only agreeing on that one thing. So one of the interfaces we're going to talk about a lot because it's super useful is compare to or comparable. So unlike the kind of toy interfaces we've been looking at so far, comparable is actually a real Java interface. It's a little more complicated than this normally, but this is an actual real Java interface. You can find documentation for it online, and here's how it works. So in Java, comparable, if you implement comparable, it means that there's an ordering for your class. That means that if you give me two instances of your class, if I give you two instances of your class, you should be able to tell me which one goes first and which one goes second, okay? Now, why is this an interface, right? Well, not every type of class has an ordering. Some classes have an ordering, right? Like numbers, right? So the numbers have a very natural ordering that we're all used to. If you give me 10 and 15, I'll tell you that 10 goes first. And if you give me those two numbers every time, I'll say the same thing, right? We've agreed on an ordering for the numbers. We've agreed on an ordering for the letters, right? That's what allows you to use a phone book, is that or dictionaries. We've all agreed that A goes before B goes before C. If you found a dictionary and the letters were all out of order, that would be very confusing. It would be very hard to use that dictionary, right? So in Java, again, if your class has a well-defined order and it's consistent, you can declare that this is true by implementing the comparable interface, okay? And what do you need to do to be comparable? So in order to implement an interface, you have to provide an implementation for one or more methods. The comparable interface is pretty simple. You have to implement one method, okay? That method is called compareTo. That method takes any object reference as an argument, and it returns an integer. Now, again, without documentation, you would have no idea how to do this. But there's very good documentation for the comparable interface. And this is a short form of it, right? What comparable should do is it should compare your class with the specific other object, and the return value indicates what order the two objects go in relative to each other, okay? So depending on whether the return value is, if the return value is 0, those two objects are essentially in the same place in the order, right? If it's negative, one goes in front of the other. If it's positive, the other goes first, right? So essentially, imagine I'm handing you two things, right? And you hand them back in the correct order, right? Or you give me a number and you say if it's 0, I say, okay, well, it doesn't matter which one goes first. They're basically in the same place in line. If you give me a -1, that means I put them in one order. If you give me a 1, that means I put them in the other order, okay? This is all we have to agree on. Now, again, you might wonder why, right? Who cares, right? Why does it matter if I can put things in order? Here's why. Because there's all this code in Java, all these Java libraries that already exist that only work if your class is comparable. But if your class is comparable, if you implement the comparable interface and provide this method, I can write code that can do the following things. I can sort an array that contains instances of your class. We're actually going to do some of these things later in the class, right, with things that are comparable, right? I can find a maximum, right? What is a maximum or a minimum, right? A maximum or minimum, the very definition of maximum or minimum depends on being able to put things in order, right? How do I find the maximum? I pick a value, and then you give me, other values, and I compare whether or not it's bigger than the one I already have, right? That's how I compute a maximum. Same thing with the minimum. So I can write code that computes minimum maximum. I can arrange your instances of your class into a data structure that's called a binary tree that we're going to talk about after spring break. So again, this is, notice why I want to kind of draw out this distinction between the provider of the interface, that's you if you're implementing a class and you decide that it can be comparable, and the user. There's all this code out there that people have already written in Java that depends on the ability to put two instances of a class in order. If your class does not implement comparable, all that code can't work on instances of your class. Once your class implements comparable, all the code can work on instances of your class, just immediately, okay? So once you provide the comparable interface, all the code out there that already uses it can now work with instances of your class, okay? Let me also kind of, one of the last things we'll talk about is this idea of a barrier, right? So interfaces represent something that we sometimes refer to as an abstraction barrier in a software system, right? So by implementing comparable, you don't need to know about how it's going to be used. You don't need to understand the sorting algorithm that can then be run on an array containing instances of your class and put them in the right order. You don't care, okay? But as soon as you implement comparable, suddenly all these things work, right? They work, right? They do the right thing. The same thing, if you're writing a sorting algorithm, if you're writing code to find the max or min, you don't have to care about how a particular type of object puts itself in order. That's up to that class, right? All you know is that you can call the compare_to method, and it will return an integer that determines what order you should put things in, right? Or what order the two objects have relative to each other, right? So again, this is like an incredibly powerful idea. It's one of the reasons we talk about it. I love this topic. So it's just really kind of brings out a lot of what makes modern computer science so powerful, right? This idea of a small little place where we have to agree, right? This interface. That suddenly unlocks all of these cool features, right? And it also allows us to work independently, right? Again, by implementing comparable, you didn't need to write all the code that exists to sort and to work with binary trees and stuff like that. That already exists. People that you don't know and will never speak to wrote that code, and they don't have to care about you at all. All they need is for you to determine for your class how you should compare two instances together, right? So now let's, I think it's probably better to come back and work on this example at the beginning of class next time. But we will basically go through and we will look at how to implement comparable, and then we will look at, we'll write a maximum function that works on an array of values that implement the comparable interface, and we'll basically show you that that maximum function can now work on anything that implements comparable, including classes that you didn't write. Okay, so I think that's where we're going to stop today. So again, as posted on the forum, we are trying to transition to a world where we can provide the instruction and the assistance you guys need in ways that don't require gathering together large numbers of students and staff, right? I mean, we essentially want to, try to limit, the potential transmission of any sort of scary things that might be out there in the world, and sort of flatten that initial curve a little bit so that things don't get as bad as they might, right? And I think we might as well start trying to do this now so that we get good at it by the time we really need it. So we're planning virtual office hours for today from 12 to 8. Those will be held online. The initial sort of point of contact will be on the forum. We will have lots of staff available on the forum. We may be experimenting with some ways of providing more support in other ways, sort of offline. Sorry, not offline, like on the forum, but through Zoom or whatever. And we'll post more instructions about that. But please, be patient with us this week. We're doing our best. We're trying to get ahead of this a little bit. And your guys' patience with us as we try out some new stuff is definitely appreciated. So MB2 is due today for the blue team. Good luck finishing that up. We'll also have virtual office hours tomorrow for the same time period, so we want to make sure that we're treating both groups equally here. Good luck finishing up the MP, and I will meet you guys again in the same virtual place on Friday. And again, I'll stay on the chat for a couple of minutes in case people have questions or whatever, and I can't even necessarily figure out how to turn this off immediately. So I'm not sure how we're going to handle the CBTF. That is one thing that we're going to have to think about over spring break. We're not the only classes in that position. We definitely have some thinking to do about that. So we'll do that. We'll get back to you. We don't have any plans for a blanket MP extension at this point. We'll see how today goes. I think most people, based on the data I looked at, are making pretty good progress. We're also, again, running up against spring break when we're really not going to be able to provide support. And I don't want to put people in a position where they need to work on the MP over break. So again, let's get through today. Let's see how things go today and tomorrow. And I think, we have a variety of options at our disposal, but I think given some of the disruptions that I anticipate over the next couple of days, I really don't want people to, have to worry about continuing to work on the MP longer than through today and tomorrow. We could extend it, we could do some other things, but please try to wrap it up today and tomorrow. Get as much help as you can off, on the forum. We'll do our best to answer as many questions as you can that way. I think, again, a lot of people are making good progress on it, but I really don't want to push it farther into spring break than the deadline already is. So virtual hours, again, we're still figuring this out. Virtual office hours will start, by messaging the spring 2020 help group. That's kind of the initial step, and then we might try to do things like set up a virtual meeting with you and the CA through Zoom or whatever. I mean, I do understand that there's things that don't translate to the forum very well, like being able to look over somebody's shoulder and point out a piece of code that's not working, and so we'll try stuff, right? I'm open to any ideas. I'm not guaranteeing that we'll be able to do as good a job as we do on the forum and providing sort of the type of in-person support that you get in office hours, but I just don't really feel like it's responsible to continue to hold office hours at this point. So we're just going to have to work within the constraints that that everybody on the core staff and the people in our community feel comfortable with. Is Discord a cool thing? I don't know. I'm happy to try it. I think we're done with Lab 7. I think that's one's in the books. So, I know some people decided to kind of start it a little late, but I think we're gonna let it go. Look, I mean, let me try to calm any fears there might be out there, right? I mean, my primary concern right now is for the sanity and the safety of everybody that's involved in this class. If there's anything I can do to kind of reduce your stress level at this point, without just blanket canceling everything and everybody in A right now, I'm happy to do that. But I do feel like probably our best move is to kind of try to wrap up some of the things that we have going on over the next couple of days, get you guys to spring break, get you out of here, and then we'll kind of reassess at that point. But I definitely don't want to do anything that would cause kind of more work throughout the rest of the week, and definitely not anything that would push things into break. We'll come back and talk more about interfaces on Friday. This is a tough concept, so if you're still confused, and I will probably a good thing to do, and maybe something I'll try is that I'll probably queue up some questions for Friday's live stream beforehand. It's really the chat feed is not, I've been trying to keep track of it, but it's sort of not super useful. So it's hard to kind of, there's a lot going by on my display, so it's hard to kind of see the questions that are actually kind of about the content, as opposed to people kind of chattering about other stuff, which is totally fine. I don't have a problem with that, but I think we need some other way of soliciting questions. So maybe what I'll do is I'll do that beforehand on the forum, and then I'll try to make sure that I get to some of the questions or concerns people might have about the material that we talked about today, do a little bit more review on Friday to touch on some of those things. I looked into Twitch, actually. I don't think the latency is that much better. I don't know if the UI is better or if there's other, good features, but again, I'm happy to do, I don't care. I'm pretty technology agnostic. I mean, I thought, unfortunately, Zoom has like a 300-person limit on the number of participants you can invite to a meeting, so that doesn't really work for us yet. But we'll try anything. Yeah, I mean, if people think Twitch is better, then we'll try, right? Okay. All right, everyone. Like I said, good luck. I'm gonna sign off, and I will see you again, same place on Friday. Reminder: no office hours today. Please don't come. I'm gonna go down and make sure that the room is locked up tight. I really don't want people to be here. Stay safe out there. Take care of yourselves. Stay calm, practice good self-care. I will see you on Friday.